Well, so far in Algebra 1, you have worked with, that's right, it's a line. And what we know about lines is they have equations, generally in the form y equals mx plus b, where there are two things that we know about lines. One is lines have a slope, and the b, lines also have a y-intercept. And there's other forms of lines that you may have seen or that you'll see coming up. Now, you've also began to work with polynomials. And so you're working with equations that have more than one term. Just like if we only looked at this part, the mx plus b part, that's a polynomial. There are two terms that are there. But what we want to begin to look at is we want to begin to look at a new shape. It's kind of like you're graduated. And so that's what we're going to do in this concept. We're going to identify characteristics of and graph a quadratic equation. So what is a quadratic equation? Well, a quadratic equation is an equation that has a standard form of y equals ax squared plus bx plus c. So what makes it quadratic? Well, what makes this equation quadratic is the exponent of 2 that's on the x. This is a quadratic equation because it has an x squared. And x squared is the largest power of x. Now you'll notice it's in order, which you've already learned about, that when we work with equations or when we work with polynomials, we like to keep the terms in order from the largest power down to the constant. So the a, the b, and the c are coefficients of the variables and constants. So we have this new word, parabola. Well, the definition of a parabola is this. It's the shape of the graph made by a quadratic equation. The shape of the graph made by a quadratic equation. And so a parabola can take the form, either one of these forms, I should say. This is a parabola. We say that's a parabola that opens up, and this is also a parabola. It's a graph that opens down. More about that shortly. So a quadratic equation makes a parabola. Now, solutions of a quadratic equation, or another word for that, zeros, Z-E-R-O-E-S. So what are solutions to a quadratic equation, or what are zeros? These are the values of x when y is equal to 0. Another phrase we could use for these is they're kind of like the x-intercepts, which is something we've already talked about. Now, there are three different types of solutions to quadratic equations that we can have. So here's the first. I'm going to make a graph, and as you draw yours, make it go through the x-axis twice. The graph that I've just drawn is a graph that has two solutions. And I'll zoom in on that, namely here and here. And our objective in this particular unit is we want to try to find those solutions. Okay. So there's one example. We could also have a graph that maybe it opens down and looks like this. And we're just going to have it touch the x-axis once right there. And this is a quadratic graph or a parabola that has only one solution because it only crosses the x-axis one time. Or we can maybe have our final contestant. That means we might not have any solutions, which means we could draw a parabola that doesn't cross the x-axis. And so here we say we have 0 solutions, 2, 1, or 0. Now, think back for a moment. If we had a line and we put an x and a y axis here, that line can only cross the x-axis once. Why? Because it's x to the first. So why could a quadratic equation have 2 solutions? Because it has an x to the second power. Now, when we talk about this other word that's fairly new, a vertex is defined as this. It's the highest or lowest place on a parabola. The highest or lowest place on a parabola. And a vertex can be a maximum or it can be a minimum. So the hills and the valleys of a parabola are really, really important. One final thing to define for you, an axis of symmetry. An axis of symmetry is, for our reference, it's a line that divides a graph into symmetric parts. A line that divides a graph into symmetric parts. So let's say we had a parabola. And let's say that we wanted to make a line so that this parabola would be kind of cut in half into 2 equal parts. So we would put it right here. So we could fold that one side of the parabola over to the other side, and it would be a mirror image. And you talk a lot about axis of symmetry in geometry as well. So that's the vocabulary. Let's take a look at it and apply it. So here we have graph A. It has an equation 2x squared minus 4x, y equals. So it makes it an equation. It is quadratic, so the graph and the equation do match up. So we're going to answer the questions over here on the right. So does the parabola open up or down? Okay, well, you'll notice this parabola opens up. Okay, and so we do say that it does open up. But what if we didn't have the graph and all we had was this? How could we tell? Well, the way we can tell if a parabola opens up or down is we look at the leading coefficient. And since the leading coefficient, which is this 2 right here, is positive, that tells us that the parabola is indeed going to open up. Now, if that leading coefficient is negative, then it's going to open down. When we talk about the number of solutions, we're looking at how many times does the graph cross the x-axis? Well, it crosses right here at 0, and it crosses again at 2. So there are indeed 2 places. And we want to write the locations of those as ordered pairs. So we have one at the origin, namely 0, 0. And the other one at 2, 0. The vertex. The vertex, remember, is the highest or lowest point on the graph. And so that's going to be right here. And so the location of that would be the ordered pair 1, -2. Now, is this a hill or is it a valley? Well, it's a valley. It's the lowest place on the graph. So we say that this is a minimum. Now, the axis of symmetry for parabolas is always going to be vertical. And what's unique about it too is it's always going to go through the vertex. Any point on this axis of symmetry always has the same x value. So we always write it as x equals. And every point on that line has the same x. And it's the same x as the vertex, x equals 1. Every place on this axis of symmetry has an x value of 1. Now, increasing and decreasing, what does that mean? Well, increasing means we're going up like we would on a roller coaster, and decreasing means we're going down. Okay, so let's take a look at the graph and see what it's doing. This graph is going down, so it's decreasing, and then it's going back up, increasing. Imagine if you had a car and you were moving from left to right. That's how you kind of look at that. Now, intervals. How do we write it? Let's start with the decreasing first. We write the decreasing interval of the graph, and we write it like this. We put a parenthesis, and we write -infinity. And then we write the x-coordinate of the vertex, 1. Now, what does that mean? Well, the parentheses are not ordered pairs because we're talking about an interval. And this is what's called in math an open interval, meaning from the numbers that are like -1,000,000 up to 1 for x. Now, these represent the x values. Okay, so if I pick any x value from -1 to 1, that graph is going to be going down. The increasing part would be from 1 to infinity. And again, we use parentheses because we're not including 1. See, right here at 1, the graph is not going up nor down. It's the only time on the graph where it's kind of neutral. Okay? Turn the page. Let's look at page 2 quick. Different graph. Let's see if we can answer these questions together. So does the parabola open up or down? Well, again, if we ignore the graph, look at the leading coefficient. It's negative. In fact, it's -1. So with the graph, we see we can verify that. So this opens down. How many solutions does the graph have? 0. This graph does not cross the x-axis. The location of the solutions, there aren't any. I'll just put a little hyphen there for that. Now, it does have a vertex. This is the vertex right here. It's the highest point. So the vertex is this time to -1, and that's a maximum because it's at the top of the hill. And the axis of symmetry is going to be right through that vertex again, and it's going to be at x is equal to 2, which again coincides or goes with the first part of the vertex. Now, this graph is different. It increases and then it decreases. So we'll do the increasing first. This time that's going to be from -infinity to 2. So if we pick any x value over here, the graph is going to be increasing. And if we pick any x value over here, the graph is going to be decreasing. So that would be from 2 to infinity. All right. Take a moment, if you would. Pause the video. A little independent practice for you. Try the bottom. See if you can answer those questions. I'll be back with the answers in just a moment. Hey, do you feel confident in how you did? I hope so. Let's check it out. We don't have an equation this time, so we just have to go off the graph. The sign of the leading coefficient, well, hey, it's going to be positive. Why? Because this graph opens up. How many solutions does the graph have? Only one, because the graph crosses at -1, 0. Right here. Which is also the vertex, -1, 0. And that vertex is a minimum. And we have an axis of symmetry that goes right through that vertex as well at x equals -1. And the increasing interval was over here, which means we are from -1 to infinity. Okay, we're increasing over here, we're decreasing over here on the left. So that would be from -infinity to -1. Aha, we've done it. We've done it. So those are some of the characteristics of a quadratic equations graph, namely a parabola. And in the next few videos, we're going to learn how to factor, and we're going to learn how to find the solutions using a little bit of algebra. We'll see you then.